How are you? Thank you for coming back. I hope you're well. Welcome back again. Today I want us to look at this most requested subtopic about stoichiometric equations and ionic equations. Stoichiometric equations and ionic equations. I want us to do it step by step for you to understand it easily. When you are writing ionic equations, these are the steps that we follow. 1. You write a word equation. A word equation in this case is that equation where you use the words. The words in this case, again, it means you call the element or the compound that you are using in the equation by name. So we are doing it step by step. So the equation that we are going to use is where we have lead 2 nitrate combined with potassium iodide. And what are we supposed to get? Lead 2 iodide plus potassium nitrate. So that is how we write the word equation. Lead 2 nitrate plus potassium iodide to get lead 2 iodide and potassium nitrate. One thing that you need to know about the reactants that we have used and the product that you have got is that this one is a soluble salt. This is also a soluble salt. So the two reactants must be soluble salts. One of the products which is lead 2 iodide is insoluble, and the other one is a soluble salt. So that is one secret in case you are told in an exam that the examiner needs you to think about two salts that you can use and then prepare or do an ionic equation. So this one that is a soluble salt, the state symbols will be aqueous, the same as this one, but this one the state symbol will be solid and this one will be aqueous. So those are the points to note. In the steps, the second one, you are supposed to write a well-balanced chemical equation. If it is a chemical equation, then chemical symbols are used. So we write the formula of lead 2 nitrate aqueous plus potassium iodide aqueous to get lead 2 iodide solid. Then potassium nitrate is also aqueous. Lead 2 nitrate, potassium iodide, lead 2 iodide, potassium nitrate. From there, we need to balance. We have one lead on this side, lead is one this other side. Nitrate ion, in the nitrate ion we have nitrogen, there are 2. These 2 is for all of them, so nitrogen are 2. The other side, nitrogen is 1, so you put a 2 there so as to balance the nitrogen. Back to this other side, oxygens are 6. This 3 is for oxygen alone, but these 2 is for all that are in the bracket, so oxygens are 6. This side we have 2, that is for everything, so 2 times 3, oxygens are 6. We go to potassium. Potassium is 1 this side, there are 2 potassium the other side, so we put a 2 there. We put a 2 on that side. Then we have 2 iodine, and the other side we have 2, so it is now well balanced. So from there, what are we supposed to do? Number 3, break the reactants and the products into ions. So this is how you do it. You make sure that you break each one of them into 2. And which ones are you supposed to break? They are those that are in the aqueous state. Anything that is in the aqueous state is the one that you are supposed to break. So we have, and you indicate it is in the aqueous state because all of them are in the aqueous state. This 2 is for the nitrate, so you put it before the ion. I hope you can see well. You are breaking everything that is in the aqueous state, so even this one is in the aqueous state, so 2 potassium aqueous plus 2 iodide aqueous, we get hakuna kushikanisha, so we get potassium iodide. This one will not be broken into the ions because it is already in the solid state. Then we have potassium and the nitrate. We have the nitrates, and they are is also in the aqueous state. So I hope it is legible enough. From there, we go back kidogo in step number 3, where we are breaking the reactants and the products into ions. I have indicated here, which is a very important point, except those that are in the solid or in the liquid or in the gaseous form. Step number 4, for each ion, indicate the correct charge. So lead, the correct charge is 2 positive. Remember, you cannot write positive 2. We cannot write it as positive 2 because when the this one is the either positive or negative. When the positive comes before the number, then this one is the oxidation number. So but because right now we want the charge, then we must have two positive, so the number becomes first. So these are the correct changes. And because this one was red 2 nitrate, and red has two positive and one nitrate has one negative, to balance the charges, because up here the overall charge for any compound should be 0. So now that nitrate ion comes with one negative, to balance the two, then we must have two nitrate ions. We must have two nitrate ions so as to balance the two, because when you are balancing the charges here, it becomes +2 for lead and plus -1 for nitrate, and the nitrates should be 2, so as to get +2 -2 to get a 0 as the overall charge. So I hope you get it, and that is how we have the correct charges for everything. So from there, step number 5, identify and cancel out the spectator ions. Spectator ions, we identify them by checking on those that have not changed, and especially when you look at the state symbols, any one of them that hasn't changed in terms of the state symbol, then you can identify that one as the spectator ion. So meaning it has not taken part in the chemical reaction. So let us begin with red 2. When you check at red 2, it is Pb 2 positive aqueous. When you look at it in the product side, it has already changed. It is already combined with the iodide. So this one we cannot cancel. Then we have 2 NO3 negative aqueous. The other side it is still the same, so you cancel it. So you cancel it, and this time we can use a different ink to do the cancelling. So we have the nitrate ion. Then we check on potassium. We have 2 K positive aqueous, the same has remained, so you also cancel the potassium ion. So we again check on the iodide, so 2 capital I negative aqueous, it has already changed, it has combined with red. So finally we can write the ionic equation. We can finally write the ionic equation. So from there we get to see that red is there, so Pb two positive aqueous plus iodide ion. There are 2 of them so as to balance the charges. Then we get the potassium. Let me write capital P correctly. We have Pb, and it is in the solid state. So this is it appears as a white precipitate. It appears as a white precipitate in case you are doing it in the form of an experiment. So that is where we began. We have 2 salts, both of them are soluble. And then for the product side, we have one that is insoluble and another one that is soluble. So let me also say this one, which is also a major point. In case you reach this part where we are writing the equation using the chemical symbols. This is a chemical equation. In case you have a problem identifying or getting the products, this is how you can do it. You see, here we have lead. It has nitrate to begin with. Then we have potassium that has the iodide part. So what happens is they actually exchange. They actually exchange the non-metallic part. So let me write it this way here. So already we are done with that question. So I'm assisting you to know, in case you are given these two salts, how can you identify the product that you should have. So we begin by writing lead 2, that is the first salt. Then this combining with potassium iodide. So they will just exchange. The lead will get the iodide, potassium will take the nitrate. So they just exchange. One more secret to understanding this subtopic is that in case in an exam you are told to think of two salts now from your head, from your brain, the two salts that you choose, one, the two of them must be soluble, both of them. Then the other secret to getting the correct answer is that once you identify two soluble salts, when you are identifying them, you must make sure that you write them somewhere and then make them exchange the non-metallic part. The non-metallic part can either be a nonmetal or a radical with a negative charge. So make them exchange the non-metallic parts or the negative radicals if those are the ones that you have. Once you make them exchange them, make sure that one of them, after the exchange, remains as an insoluble salt. And how can you know the insoluble salts? There is this, I would call it like a song that is usually in the KLB book 2 about the solubility of salts. And how you can identify those salts that are insoluble is, for example, if you consider the part of the solubility that says all sulfates are soluble except, you see those parts that talk of except what? Lead 2 sulfate and barium sulfate. So these two are insoluble. They are insoluble salts. So they are supposed to be among those that you are targeting on the side of the product. Another song says all chlorides are soluble except silver chloride and lead 2 chloride. And where you hear of lead 2 chloride, you can also have lead 2 iodide. Like in our case, you see, we used potassium iodide so that when we interchange them, we can have lead 2 iodide. Then we have all carbonates. All carbonates are insoluble except those of group 1 elements and ammonium. So as long as you're not using any element like potassium, lithium, sodium, those are group 1 metals, or even ammonium to combine with the carbonate cation, then any other carbonate is insoluble, meaning you can also be targeting any one of them as the salt that you get in the for the product side. Finally, though not the final thing actually, so before we go to the final thing, you see the way I have arranged my equation. I have done it in a way that there is no product that is spilling to the other side. So you have to arrange the question in a way that even though it's not a must you draw a line, but you must make sure that from this part, which is the tail of the arrow, if you are to draw a line there, all the reactants are supposed to be on the left, and from the head of the arrow, all the product should be on the other side. So you have to arrange your question in a way that the reactants remain on their side and the products remain on their side. So let me now give you an assignment. But again, before then, let me take you back to where we started, and hopefully you can see everything. So these are the steps. Number 1, write a word equation. Number 2, write a well-balanced chemical equation. Number 3, break the reactants and the products into ions except those that are in the solid or the liquid or the gaseous form. Then number 4, for each ion, indicate the correct charge. Number 5, identify and cancel out the spectator ions. Those are the ones that have not changed. And especially if you check on the state symbol, then you can easily know which ones did not take part in the chemical reaction. Finally, write the ionic equation, and the ionic equation will only have those ions that took part in the chemical equation. So the equation that we used had lead 2 nitrate, which is a soluble salt. It also had potassium iodide, which is also a soluble salt. Then we have lead 2 iodide, which is an insoluble salt. This is actually what will be the precipitate. Potassium nitrate, which is also a soluble salt. Do not get confused as to why I had to put the state symbols here. It does not mean that you indicate them in the word equation. I only used them to show you the meaning of soluble. Soluble means it will be in the aqueous state, but do not indicate the state symbols on the word equation. The state symbols are correctly put in the chemical equation. So this one is the word equation, and this is the chemical equation. So state symbols should be put in the chemical equation. Here I just indicated them to show you the meaning of soluble. The state symbol will be aqueous. This one is also soluble, it will be in the aqueous. So this was just for explanation purposes, but not to mean that you should have the state symbols in the word equation. So from there we wrote the well-balanced chemical equation. So here we do not have one. It was a way of showing you how you will break them, the line where you should break them. Here you are breaking them from there. So then you indicate each one of the ions with the correct charge. Then finally you cancel the spectator ions, those that have not changed. If you check on this one, it was initially in the aqueous state, it has changed. This one was in the aqueous state, it has not changed, so you cancel it out. This one lead was in the aqueous state, it changed, so you won't cancel it. Nitrate ion was in the aqueous state, you again cancel it. So then finally you have the ionic equation with red 2 ion aqueous, 2 iodide ions aqueous to get red 2 iodide, which is in the solid form. And I said if you are to do qualitative analysis, I mean the practical bit of it, that will be seen as a white precipitate. So in case you wanted to prepare this kind of salts in the lab, you are supposed to mix 2 soluble salts. The insoluble salt will precipitate out as a solid, and the soluble salt will be left in the solution as a filtrate. Then from there you are supposed to filter the mixture to correct the precipitate. It will be left on the filter paper. Then you are supposed to then wash the precipitate using distilled water, then dry it between filter papers, and that way you obtain the pure salt. The pure salt in this case is the insoluble one. This method that I have used in showing the ionic equation is one of the methods of preparing salts that we call the precipitation method or the double decomposition method. So right now I want to write you the assignment. I want to write you the assignment. I want to write you the assignment, and in the assignment I want you to try this one where you have silver nitrate, where we have silver nitrate combining with sodium chloride. So that is one of the assignments. So you complete the word equation, write the chemical equation, have the charges, identify the spectator ions. You can also try this one where we have barium chloride. So assignment 2, where we have barium chloride combining with copper 2 sulfate. So again you complete the equation. Those are the two parts of the assignment. In case you have any question, you can ask. Please ask in the comment section. Let me know where you are finding it difficult. We are here to assist each other until we get that A grade that will give you a good course. So may God bless you, may God bless your memory, may God bless your mind. And other than trusting God, we also have your own part. You need to do more and more questions, do more and more practice. Practice make perfect. It make you perfect or in everything that you do. So may God bless your memory. May God give you more resources to reach out to this channel so as to benefit from it. Please subscribe subscribe if you have not yet. Please, if you have, thank you very much. The new subscribers, karibuni sana, welcome, and together we make chemistry easier for all the students. There is no student who is stupid, who cannot grasp anything. Every person, every student is blessed with good mind. The only thing is to make sure that you get rid of the negative attitude and you also practice. That way God will bless the work of your hands. So may God bless you. Have a good day wherever you are watching me from. Please subscribe, please share, please tell a friend to tell a friend, and we all join to assist each other in chemistry. Thank you. May God bless you.